Well, it's time for another the Astro 30's Electronics Lab video, but before we do that, let's have a look at the dog anus clock. So the long hand is pointing straight up to the 12, so it's something o'clock, and the short hand is pointing to the 8. So it's 8 o'clock on the dog anus clock. Greetings, the Astro 30 here yet again with another project from the Short Circuits Volume 2 project book. Now that we've finished looking at the dog's anus and know what time it is, we can move on to what the topic of today's video is. In this one I'll be looking at a Beam Me Up intercom. It's basically a two-way intercom, hardwired. What would be more impressive is if it was actually wireless, but it's not. So anyway, this is project number 10 from the book. You can use it to talk between two parts of a house or leave it on and use it as a baby monitor, so it's actually a dual function. Now, it includes PCB speakers, 6 meters, which is quite impressive, of connecting wire and all electronic components. It doesn't contain any jiffy boxes or anything to mount the project into. You have to buy them separately. Kit requires 9-volt battery, the instructions or the project book, and optional to buy UB3 jiffy boxes, as I just previously stated. And here is the project in the book here. It's a 2-station intercom, a fairly small circuit board, and just a switch and a couple of speakers and a 9-volt battery. Over on the next page here we've got the schematic, and the heart of it is this LM386N, which I hate and loathe. It's configured into its 200 or gain of 200 using capacitor and resistor across pins 1 and 8. Now over here we've got an 8 ohm to 1 kilo ohm transformer. They're using that as a step-up transformer because we're using either one of these speakers at any point in time as a microphone instead of an output device. The speaker itself is not a good microphone because the impedance is so low. So we step up the impedance by connecting it to this 8 ohm transformer, which is normally used as an output transformer, but we're now using it as an input transformer. So we're going from 8 ohms to 1 kilo ohm, and then it's going into this first transistor here, which is just a basic amplifier, which is then fed through a volume control into pin 3 of IC1, which is the LM386. Pin 5 is then fed, which is the output, via this 220 microfarad capacitor into this apparently 3-pole 2-position switch. I've never seen one of them before, but yeah, anyway. And this basically switches between listen and talk. So in the off position here, which would be the base station is in listen mode, the path of the speaker goes to here, which is the local speaker. So we're actually monitoring now on the unit that the circuit sits in. If we switch to on, we now use this speaker, which goes to the input here, because we're also switching the input, goes into the input, out the amplifier, and then off to the remote speaker at the other end. And there's a little remote push to talk switch there. It's a very simple circuit, there's not much to it. What is actually interesting though is this transistor used here. What this is being used as is a switch. So if we looked at the PTT switch goes between the negative and the base of this transistor via the 6.8K. So when this switch is pushed in, negative is going up to the base of this transistor, turning it on, which is allowing then current flow through the rest of the circuit. So this is acting as a switch to turn this off when it's not actually doing anything. And the same is also true that when the master station or the local station pushes its switch to the on position to talk to the remote station, it also turns the this transistor on, as we can see here, switch 1C brings up ground to this transistor, turning the circuit on. When it's off, the whole thing is off, so you're actually saving battery power. It's not constantly sitting turned on all the time. The optional baby monitor part, which is switch 3, is when this is in the off position or listen position, this switch is then wired to ground, and when you close the switch, it completes the ground circuit to this base of this transistor, turning the circuit on. So then the circuit is live all the time. So we can choose whether or not to do that on or just leave it as an intercom as it was originally designed. I hope that explanation actually made sense, but I'll soon find out in editing. It's not that difficult a concept, and the actual construction of this wouldn't be all that difficult either. Over on the page is a tech talk of how it actually works, basically what I said, and finally the optional wiring diagram for the remote to local station. And here's a close-up photograph of the circuit board going back to basically the 80s. That's basically what circuit boards were. It's not what it actually looks like now. And quite frankly, you don't really need the instructions unless you want to actually see the circuit diagram for it more than anything else, and a brief description of how it works, as well as other information of how to wire it up. But actually building the circuit, well, there's our bags of components. 6 meters of hookup wire, which I'm probably not going to use at the moment. 2 mini 57mm speakers, I think they are. And there we go. Let's look for the circuit board. There's the circuit board there. Again, it comes with the information about the book. You don't need that. It's a fairly small circuit board, as I said. Not much to it. You can use a trim pot or a rotating pot, rotary pot. And what's interesting is they do actually give us a 3-pole dual throw switch. You can't see it because the solder's in the way there. If I can move the solder out of the way of that switch, which is not as easy as it looks. There we go. But you can see that that's got like 9 terminals on it. So that's a very interesting switch. I've never actually seen these available to buy in Jaycar, but someone obviously makes them. There's our output transformer, which is going to serve as our input transformer. Capacitors, everything's all separated into different sections. So we've got over here on the very far right, we've got PCB pins, which is what we would solder in first. We've got our resistors, and they only give us a trim pot here for the volume control. Not exactly happy about that, but I'll have a dick around and see if I can find a pot that will fit that. Gotta know what type, what pot it is. They are using a 20k pot. Well, you could probably get away with a 10k there anyway. And then it goes capacitors, and then miscellaneous hardware, plus some hookup wire, which is nice. That hookup wire will be for the switch. There's the push button for the remote station. As I don't have the cases to put them in, I'm going to have to use a lot of jumper wires. The switch itself will be soldered and connected to the main board, but the actual connections to the remote and master station and the push switch, I can use a jumper wire as to mimic that. Well, looking around in my parts drawer, all I could find was this B50K, which is a linear pot. It's probably alright for this type of circuit. Miniature pot, which is a 9mm, and I can always change it later, I suppose, but yeah, there is an option on this board to fit that in there, and yeah, there is just enough meat sticking out the end of it to work okay. So I might use that pot there for this. I suppose once it's in a jiffy box it doesn't really matter, but yeah, I've got the option of changing the pot later, but for getting it working and not having to use the trim pot there, which is annoying, I'll just use this Okay, to start construction, I'm going to do all the PCB pins first. Might want to prop that up on something just so it doesn't force them to come back out again. I don't know how well this little trick that I'm about to do is going to work, but we'll soon find out. Well, I might not do all of them at once because that might be a little bit difficult to get that right. That was what I was aiming for. I tend not to use the supplied solder that they give you with kits because I think it's that lead-free crap and they give very dull joints. So I'll just use my 40% lead. Yeah, 40% lead solder. Alright, that's all the PCB pins installed. Albeit not all of them are actually flush, as they should be. So, they are now. Right, I was about to move on to resistors and I found there was an extra PCB pin over, so there's actually 14 of them and I'm buggered if I can see where it goes. I can't see anywhere for an extra PCB pin. I may be wrong, but I think this is a spare because there is not anywhere else to put one, so I'm not going to worry about that. So I'm going to move on next to resistors. That looks like a 6.8k, or it could be 68k, hang on. Oh, when in doubt, measure it, as well as fart. So what have we got here? Yeah, 6k8, I was right the first time. Okay, so I'm just going to go around and continue farting and putting in resistors. And it's starting to smell like a toilet in here. Alright, that's all the resistors installed. I'll just cut off the excess leads here, which tend to always stick to my finger. I don't know why. How much did this kit cost me? About $28 and some change. It is kind of on the expensive side for what it is, but they do supply you with 6 meters of audio cable, so I suppose there's that. That's all the resistors installed. Now, they didn't provide an IC socket for the LM386. I'm going to use one because I just happen to have them. So that is what I'm going to install next. In your case, what you would do is just solder in the IC directly last, but it may become a little bit awkward with other components in the way. So that's why it's always a good idea in that instance to use an IC socket, because at least, well, you've got better accessibility of just plugging in the IC rather than trying to put it in, solder it and yeah, whatnot. So I'll just finish soldering off this IC socket and we'll move on. There we go. Now in the next bagged part they give us two transistors, sorry, a diode and some capacitors. So this 1N4004, I believe it is, which is used over here as a wrong way battery connection protector. It's basically just a half-wave rectifier. So I'm going to install that next, as its profile is fairly low. And really, in the grand scheme of things, you're not going to kill the diode by soldering it in now and then soldering other components around it. Nor are you with transistors or anything like that. The only components that you should be careful of with respects to soldering in circuit, mainly to do more with static than heat, are CMOS based ICs. They tend to not like static and they tend to not like a lot of heat. So, but general purpose components like, you know, these transistors, it's not going to hurt them. That's the P10 200, so I might as well install it next whilst it's in my hand, which goes there. You could probably use a BC558 in place of this. I don't think it would really matter that too much. I don't think the general HFC, this is the transistor that switches the power on to the rest of the circuit, so I don't think its HFE or gain is all that terribly important to the operation of the circuit. However, this PM100, as that's the first amplifier stage before the IC, the HFE or gain parameters of this particular transistor would be kind of important. And this is a PM100 that goes there, if I can get the legs to agree with me. Right, that's the two trannies installed. Next we'll move on to capacitors. I've got some polyester ones, green caps, and this 334, which is a 0.33 microfarad or 330N, which goes over here like so, and there's a 220N, which is what this one is, 224, that goes next to it. And they give us multiple holes to install the capacitor so it fits in the board without the leads being stressed too much. It's really much of a muchness which ones to use. Neither's going to work great. So I might stick with that one. I still don't like it. So what I might do, I'll bend that lead out, bend that lead out, and then choose a better pitch. So I've bent the legs of that capacitor at right angles to each other so that they fit the hole pitches a bit better and it looks a bit neater rather than having the legs bend inwards. It's just neater. And now we're up to electrolytics, but what I might do first is stick this 50k pot in, which will probably end up coming back out later. Yep, that was a fail. Alright, so I'm going to do that. Just do the center lead, tack him in, so I can actually turn it upside down now. Get this tool to agree with me, and then push it back up so it's now flush, and then solder the rest of it, going back over that first pin again. And so this is probably going to come back out and I'm going to stick another pot in there one day, maybe, I don't know. Anyhow, that's the pot in. So now we've got a bunch of electrolytics. Okay. Just as a side note here, you don't really need to buy the kits. If you've got the parts and the schematic, you can always breadboard out the thing to test it and see what it does. Which for some of them in the near future I might do rather than buying the kit. I'll breadboard them out. That is, if I've got all the components to do it with. I may or may not have. It depends. I've collected a lot of components over the years. That wasn't close enough. I've collected a lot of components over the years, I don't know if I've got all the right components, if you know what I mean, like specialty ICs and stuff like that. So now we're on the way to a completed circuit board. So what we got left now is the output transformer, which is in the next bag here. So here's our 1K to 8 ohm step up transformer, but it's in the configuration of the circuit, it's being used as a step down transformer. So it only fits in the board one way. I've got two hole sizes, like hole spacings here for different types of transformer. Might be a little bit of an awkward now with that capacitor there, but we'll get it in there somehow. I think I just boogered that up. That should be going over there. And that one should be going over there. There we go. There we go there. That didn't look like it soldered properly. So that's the transformer installed, and that would actually complete the construction of the main PCB. There is nothing else to do to it. Transformer's in, except put the LM386N IC in. This is actually an LM386N1, but anyway, that's beside the point. This is the difference in the output power between the two types. One's 360 milliwatt, the other one's an 800 milliwatt. There we go. So, there we go, done. The circuit is now complete. So now we can go about wiring up our main switch. The secondary switch for the remote station, which is this push button here, I will just use a jumper across it to make it work. Excuse me, and yeah, hook the speakers up with jumper wires as well, save a lot of soldering. So the only thing I'm going to be soldering is this monster switch. But we'll look at the instructions for that. And it gives you all the color code wires, where to put them on the switch. Okay, so there's the wiring for the switch there, and according to this, I can actually, these two orange wires on either side of the switch could potentially wire directly to the local speaker, which is what they're supposed to do anyway, and then the purple wire goes back to there. The remote speaker here is wired to the PCB, but normally that would not be, and it says down the text that the remote speaker and remote switch would not be mounted this way. This is just for demonstration purposes to show the wiring. But yeah, it's pretty simple. So one speaker can actually be wired directly up to the board here, and for testing purposes, yeah, I'll just use a couple of fly wires or something to connect the second speaker. Switch is not necessary. 9 volt, I don't know whether I'm going to use the connector or whether I'm going to do something different there. Anyhow, it's color coded here, got 2 yellow wires there, 2 orange, 1 red, which is the input, 1 green, 1 purple, and 1 blue. So that's the way I'm going to wire it, and there's 1 tag on the switch not used, so all 8 of the 9 are used. So let's get going with that. Wow, they really give you a long length of wire. That's the orange wire, that's all the length they give you. So I suppose if you cut that in half it should be long enough, but yeah, that's ridiculously short. So it would have been nice if they gave us like 30 centimeters of the stuff, but no, they didn't. This is awful fiddly, but it can be done. I've already cut the wire in half and stripped back the other end and joined the 2 wires together as it's supposed to, because this one goes to the local speaker on the positive side. And I'm just checking my diagram as to where to wire stuff. And if you follow this color code, you can't really go that wrong. but it probably wouldn't help if you're colourblind. But I suppose you could work it out with shades of colour. I didn't quite twist those wires together enough, but it'll still serve the purpose. Okay, that's 2 wires done. Okay, and they don't give me a purple wire or even a pink wire, so I might use a white wire instead. That just goes to the local speaker, and then the blue wire goes back to the circuit board. So I'm going to keep all the wires from the switch back to the circuit board the same length, and the one going to the speaker, which is going to be a white wire here, will be left at its full length, I guess, because it'll all work out once it's in a box. That is, if I ever decide to buy a Jiffy box for this. Probably like one of those other projects that I've done before. It just stays the way it is, never being mounted into a enclosure. This seems to be the way it always is. So I'll just tin the end of this wire. This one's going to the circuit board end, and just double check where that's going. That's going into this center portion of this switch. Okay, and that's all the wires soldered to the switch. That is the most time consuming part, I suppose. The purple wire that went to this portion of the switch I've replaced with a brown wire because it doesn't have a brown one in the kit. I mean a purple one in the kit. All the other colours are the same as they should be, so now all it is a matter of just soldering each of these wires to where they go on the PCB pins of this circuit board. Okay, so that's that wire there. I believe that's the switch or wire to the circuit board. Yes, it indeed looks like it. So I need this white wire to come off from where it goes to the main speaker. So I'll trim him down. So that was going to be the purple wire from over next to the blue, this one here. So, right, so that's our local speaker's negative connection. So that's going to go to this wire here. Okay, it's going to go across the negative terminal of the speaker. You are really supposed to use the eyelet, but I think it's much easier just to solder to the top. Same with the positive, which are these 2 orange wires on the right here. They come from the switch, get joined here. My hand's probably in the way. Indeed it is. Whew. Smell coming off of that speaker, man. Jeez. Right, so that only leaves our power supply connection, plus minus 9 volt there, and the remote speaker connection, which is down here, and the push button switch, switch 2A, which goes between that and and it goes like that. Oh yeah, between here and here. There's 2 pins here, so that's easy enough to put a jumper wire on. I might use a 9 volt battery. Why not? It comes with a 9 volt battery clip. Might as well use it. So I will take that out of the bag, and they're already pre-tinned anyway, so I'll just tin and burp the connection points, lose whatever that was, the side cutters, onto the floor. Okay, so that's the battery clip installed. Give it a little bit of volume. All I need to do now is find a 9-volt battery, which I've got. And I'm not sure which direction this switch needs to be switched in. We'll soon find out. And I need to also find a couple of jumper connectors to connect up this speaker with so we can test it. Okay, I've got a fresh 9-volt battery. I've got everything hooked up. Secondary speakers hooked up to where it needs to go to make sure that those wires don't short. So I'll plug this battery in and see what happens. I heard a pop. Yeah, it's working. Testing. Testing 1 2 1 2 2 2 2 2. Put it into listen and short. As I push the torque on the remote. Yeah, we just make it feedback. You dickhead. Wonderful, it works. And it was relatively painless to build, so we can't really do much more testing than that except continue this project at a later date by placing it in a Jiffy box and wiring it up. But yeah, I'm going to end this video here. This was the Short Circuits Volume 2 Project 10 two-way, two-station intercom. About 28 bucks from Jaycar. Very easy to build. Very happy with how it turned out. Yeah, I'm the Astro 30, and if you enjoyed this video, please remember to rate, comment and subscribe below as usual. And you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyhow, this is the Astro 30 saying, penis.